If you don't have what I have, ask, because I cannot read your minds. Give yourself 2 for everything. So you have a bit of a sliding scale, like if you forgot a negative somewhere. Let me go down a little more so you can see number 2. So there is 1 and 2. Remember, the blue is exact. That's the math class answer. The green is the real life answer that you would give in like a physics class or something. Yo.
So if we rounded our stuff like the whole number instead of our approximate.
So you said 1 and 4 there?
I did 1 and 3, so it was like probably 3.5 something.
Well, then it still would have been 4.
Oh, well, yeah, it was. But that's still
Well, I mean, I guess, sure. It's a pretty big round to go from 3.6 to 4, though, right?
I thought we were just supposed to do that.
Yeah, it's cool. It's fine. The point is, you did this, right? That's what I'm looking for here. That you actually know what this means if you've got to get a real, well, not a real value, if you've got to get an estimated value. That's fine. Any question about 1 and 2? How many people attempted this as an actual test, like I suggested? Like you didn't use your notes? Half and half? Yeah? Okay. Any questions about 1 and 2? Please don't bother writing it all down if you didn't bother to do your homework. It's recorded. If you care enough, you can check it then. I have a lesson to do still today. So if there are no questions, I will move along. There is 3 A and B. I would accept either answer here, remember, right? Technically, it's 2 equal roots, but on a graph, you'd only see 1. And this one is, of course, no roots because it's negative. And then since this one is already factored, the easiest thing to do is just to run it through with both equaling 0. Any questions up to number 4? Excellent. There is 4B. Oh, I didn't highlight. 4C. And I can cram 4D and E. Not quite. 4B and C, there they are. D and E, there they are. Now, could you have expanded all of these and used the quadratic formula? Is that allowed? Yes. Why then did I say best method possible? Because you should have all 3 in your math arsenal so you can save yourself some time. And 5. This was the last thing we did yesterday. K had to be less than 8/3, so we check, and it worked. Because 0 is less than 8/3, and it worked. When do we really have to check these? If I ever have 2 options, then I really got to do the number line. Everybody with me? But if it's just one thing, chances are you're right. Okay? Everybody is good? So I believe, if I'm not mistaken, that is 2, 4, 6, 8, 10, 12, 14, 16, 18 out of 20. And then we move on to page 98. So everybody add it up. Take a moment. Make sure that you don't need to ask me questions. I'm going to wait a moment for you to be comfortable with what is going on. So, we're going to start with the easiest possible one, and then we're going to talk about how it gets manipulated. All right? A quadratic function has form. The easiest quadratic function we can draw is this. Everyone agrees, yeah? It's an independent variable. It's a dependent variable. There's no other math involved. That's as simple as it gets, right? How, if you were going to put this on a graph, would you put it on a graph? What would you do with this to get it over here? Right, you make a table of values, right? Just like you would for a line. X, Y. Now, since it's square, we know it's going to curve, yeah? So in a line, you only need 3 points. Because once you have 3 points in a line, you know it's a line. On a parabola, you should have 5 points. Okay? So I always use those. What is negative 2 squared? 4. What is negative 1 squared? 1. What's 0 squared? What's 1 squared? 4. And 2 squared? Sorry, 1 squared is 1, and 2 squared, 4. Right? Let's put it on the graph. 0, 0. Good? 1, 1. 1, 1. 1, 1. 2, 4. Negative 1, 1. And negative 2, 4. And it makes that curve, yeah? Now, we already know some of the terms here. What do we call that point right there where the parabola turns back up? That's our vertex. Right? Now, in a line, we know there's a pattern, don't we? It makes the slope rise over run, right? So let's see if there's a pattern like that here. When I go this way, 1, I went up how far? 1. When I go this way, 2, I go up how far? 4. Because I went from the vertex up 4. Everybody with me? What is your guess for if I go this way, 3? I'm going to go up 9. Everybody understand? What if I go right 17? How far up will it be? Out come the calculators. 289. Everybody understand? It goes up by the square of how far we went sideways. Everybody good? All right. So, please note, all quadratics have this pattern. Oh, okay. I didn't see that. I just saw you. And I was like, I don't smell toast, so I hope you're okay. From the vertex, we move horizontally on the x-axis and vertically by the square, not square root, by the square of the x adjustment. All right? And that is how every parabola starts. Everything else is an adjustment to that. Everybody cool? Just like if we drew a line, and don't draw this, just, please let me have some graph paper here somewhere. Don't draw this line. Every line is an adjustment to this basic line, which is y equals x, right? If I put a 2 in front of x, it gets steeper. If I put a -4 there, it slides somewhere on the line, yes? But everything starts from a base. Same thing with parabolas. Everybody cool? All right, so let's talk about these things now. We already know what the vertex is. What is the vertex? The vertex is the point where the parabola turns back. And remember, we are working with y equals x squared. In y equals x squared, what is the vertex? 0, 0. Remember, every point on a graph has 2 coordinates. All right, now the next one. There's a new word there. Axis of symmetry. What does symmetry mean? Same on both sides, right? Right? So let's look at this parabola. I went over 1, up 1, right 1, up 1. The symmetrical option is left 1, up 1, yes? So that tells us that right down the middle here, right through the vertex, if I fold that parabola over, I have the exact same thing, don't I? That is what the axis of symmetry is. It is a vertical line, and if it's a vertical line, it's x equals something, right? X equals m, some number, if it's a vertical line, which goes through the vertex. And what is it on this case? It's x equals what? 0. Everybody cool? All right. X-intercepts. That's when the parabola hits what? Hits the x-axis. Now, we know lots of stuff about that already. We know that's also called the roots. We know there can be 1, 0, 1, or 2. We also know it is x, 0, because the y value will always be 0, yes? What is it in this case of the regular parabola? What is the root? Because there's only one, because it only hits the x-axis once. It is at the x-intercept is 0, 0, right? Same as the vertex. Everyone's cool still? Okay, what's the y-intercept? Obviously. When the parabola hits the y-axis. Will a parabola always hit the y-axis? Yeah, because it's spreading out, right? No matter how far I go out to infinity on the x's, eventually it's going to hit the y-axis somewhere. There's always a y-intercept of a parabola. Is there always a y-intercept of a parabolic relation in real life? Not necessarily, right? Because maybe it's on the negative side of x and it's something that couldn't be negative. Everybody with me? Always has a y-intercept as a parabola. And what is it in this case? It's, of course, 0, y. And what is it with this graph? It's again 0, 0. Because it only hits the y-axis once. The domain. The domain are the x values, yes? If your parabola is a vertical parabola like we are studying right now, what is its domain of the parabola? Not of a real life relation, of the parabola. Look at the graph. What's going to happen with this line as I go further and further up? What's going to happen to this distance? It's going to spread out, right? How far will this parabola go upwards? Till infinity. So how far will it spread horizontally? Infinite. So a parabola, the x values, a parabola has x is a set of real numbers. All the real numbers of a parabola. Is that true of a real life situation represented by a parabola? No, because often we can't have negatives. Everybody understand? Okay. So, we know it. It's infinity to infinity, all the real numbers. What's the range? That's our y values. Now, our y values have a limit, don't they? What is the limit? Not in this case, but in all cases. What is it? I think I heard you just say it. It's the... No. I thought I heard you say something else. Look at the graph. The range is the y values. What point on the graph stops the y values? The vertex. The range is limited by the vertex. On a real parabola, right? So, if my parabola goes up, where is the range stop? It stops right here, yes? Everyone agrees? Is that going to be a minimum or a maximum? Minimum. What if my parabola is turned upside down? What's that become? A maximum. So the range is always y is greater than or y is less than. Could it be equal? Yeah, it can be either of those. What will it go to? What will it go up or down to? He waited patiently. Look at the drawing. How far up will that parabola go? Forever. How far down would it go if it was flipped over? Forever. So what is the upper limit of a parabola? Infinity. What's the lower limit of a parabola? Negative infinity. Everybody good? Yeah? Is that the same of a parabolic relation? No, because we wouldn't count to infinity. Is everybody cool? All right, let's do some practice and see if we can do this. There's the easiest one. It says use the graphing calculator, but we're not gonna. All right, what's this guy look like? We already know. It starts at 0, 0. And because it's the normal one, I'm going to go right 1 and up how far? 1. 1 squared is 1. Then when I go out 2, how far up? 4. And there's my graph. 1, 1, 2, 4. Negative 1, 1, negative 2, 4. What do you notice about the y values? They're the same. And the x values are mirror images of each other because this is our axis of symmetry. Everybody cool? Now notice, please, I have written a new form. We're going to come back to that in a minute. So you're smart kids. If I wanted you to graph this, what would you do? I would use this. And what 5 points did I say are good points to choose? -2, -1, 0, 1, 2, right? Well, what's -2 plus 3? What's 1 squared? 1. What's -1 plus 3? 2 squared? 4. What's 0 plus 3? 3 squared is 9. What's 1 plus 3? What's 4 squared? 16. What's 2 plus 3? What's 5 squared? Now there's a problem here, isn't there? Because when I go to x is -2, 1, 2, my y value is 1, correct? And then when I go to -1, my y value is what? My y value goes up to 4, doesn't it? Everybody see that? And then when I go to 0, my y value is up to 9, isn't it? Well, what's going to keep happening? Keep going up. So do I have a left side of the parabola? No, so I better check it. So -2, what is the next logical number to check in the negatives? -3. What's -3 plus 3? What's 0 squared? There's my vertex. Right? Everyone sees this? Now, once I have my vertex, this is -2, 1, correct? This is -1, 4, correct? This is 0, 9, correct? Well, what's this one going to be? You just saw it over here. -4, 1. What's this one going to be? -5, 4. It's the same value. What's this one going to be? -6, 9. Why? Because here is an axis of symmetry. Now, look closely. What would happen if I took this black parabola and I slid it over here? It would be the same, wouldn't it? So what happened to those two equations? What is the similarities between those two equations? X squared, yeah? But when I put plus 3 with the x, how far did that vertex slide? It moved -3, didn't it? If something happens once in math, what's our best guess for it happening again? Well, let's see what happens. How is number 3 different from number 2? It's -2. Well, when it was plus 3, we moved the vertex left 3. What do you think we're going to do for this one? Let's move it right 2, which would mean my vertex would be 2, 0, correct? All right, and then did we follow the same pattern, over 1, up 1? So do you think we should follow that same pattern here? There's 2, 0. What's right 1, up 1? Three, 1. What does that automatically make this one? 1, 1. If I go over 2, how far up do I go? 4. So what's this one going to be? 4, 4. What's this one automatically going to be? 0, 4. And there's my graph. Everybody cool? Everybody good? So what does that tell us? If I have a number with my x in brackets, where does that vertex slide? You've just done it twice. One of you can put this together. It's the opposite to that number. So now let's look up at our new form. Where do you see that number? P. P is our horizontal adjustment of what? What moved? Of the vertex. Everybody cool? And there's a negative there to remind you, you go in the opposite direction. Yeah? Okay. What's different about this one? There's no bracket. So if I had this, what would I do? What would it look like? It would be this guy, right? 0, 0, 1, 1, 2, 4, negative 2, 4, right? But after I get that 0, 0, now it says I'm minus 4. So where do I go? Down 4. So what's my new vertex? 0 minus 4, right? When I go over 1 and up 1, what's this point become? I move right 1 from 0. What is it? 1. I move up 1 from negative 4. What is it? Minus 3. What is automatically this point then? Negative 1, negative 3. When I go over 2, how far up do I go? 4. So what is this point? No. I've gone 2 to the right from 0. So what is it? 2, 0. What is this point automatically? Negative 2, 0. So what does that negative 4 tell us? I dropped it by 4. What do you think would happen if it was positive 4? I'd go up by 4. So let's look at our new form. Where do you see that number? The Q. That is our vertical adjustment. Now, is that Q positive or negative? So do we do what we see or do we do the opposite? We do what we see. That is what we see. So, now all of you should be able to do this sixth one by yourself. Remember, we pretend like none of this extra stuff is here. Because that's the basic parabola, yes? That's going to be 0, 0, 1, 1, negative 1, 1, 2, 4, negative 2, 4, right? But we have adjustments. Where is that vertex going to go? In our heads, it starts there, but where is it moving? No. To left? Our horizontal adjustment is the opposite of what we see. We see negative 2, which is 2 left. Gervir, you're right. But what do? We got to move it 2 to the right. So it's going to move over 1, 2 to the right. What's this mean? 5 up. 1, 2, 3, 4, 5. So what's our new vertex? 2, 5. Right? Does anything else change? Does anything else change? No. Now, ladies and gentlemen, just for my purposes, I'm going to move this way down here and consider that 2, 5. So I have room to show you. We've made no other change, so I go 1 to the right, and how far up? One. So what is that point right there? What's 1 to the right? 3 and 1 up. What's this point automatically then? 1 to the left, which is 1 and 6, because I keep the same y value. If I go 2 to the right, what is my x value? 4. And I go up how far? We've done it 5 times, ladies and gentlemen. I would go up 4, so this point would be 4, 9. What would this point be? 0, 9, because the y's stay the same. Everybody good? All right. Now, you attempt just this one. Do not touch these 2 yet. Just attempt this guy. Go. Label it 5 points. Vertex and the first 2 on either side. Go. Ladies and gentlemen, I sound exasperated and pissed off because I am exasperated and pissed off. I am asking my grade 11s to count. I am not asking you to do any math. I am asking you to frickin' count. Why am I hearing silence when I ask you to count? I am more than willing to get the YouTube video of the count up, and we can all practice. 1 sheep, 2 sheep, 3 sheep, But I shouldn't have to because you're in the 11th grade and I'm asking you to count. Thanks, Gervier. You're already getting an A because you can count. Apparently, the other 25 of you, what's 1 more than 5? If you're in trouble, use your calculator. 5 plus 1 equals. Then maybe we'll be okay. Is there something new here? What's new? The 2 is in front. We know what to do with stuff on the other side, but that's different. So how do we resolve it? We go back to a table of values so we can't screw it up. X, Y. What are the 5 X's I should use? -2, -1, 0, 1, 2. What is -2 squared? What's that 2 do now? Multiplies. What's 4 times 2? Click, 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 equals 8. Hey, first try. What's -1 squared? 1 times 2. Click, 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 equals 2. Hey, first try. Here's a real tricky one. I'm not sure I'm going to hear a lot of answers. What is 0 squared times 2? 0. Well done, everyone. What's 1 squared times 2? What's 2 squared times 2? 8. Let's graph it. 0, 0. Over 1. How far up now? 2. Over 1 up 2. Over 2 up how far? 8. How far should it have been? 4. But now we're going up 8. When we went over 1, we should go up 1, but now we're going up 2. What's the pattern? What does that number do? Multiplies the vertical, right? So what would be if I went over 4, how far up would I go? Well, normally I go over 4 and I go up the square of 4, right? Which would be 16. How far up would I go now? He waited for his grade 11s to do 16 times 2.
I said the square times 2.
So say the number. 32. All right, now we have covered all of these things, haven't we? We've covered the P and the Q, but now we've added the A. The A changes the stretch. So, let's have a look at this one. If there was no A there, how would we graph that? Where would our vertex go? No, there's no brackets. 0. That was where we would start if there was no 4 there either. That's where it starts. But there is a negative 4 there, so where's that vertex going? 0 minus 4. Everybody agree? Please say yes. Just humor me, even if you don't get it. Just say yes. All right. Now, normally, I would go 1 more than 0, which is 1. And I would go up how far? 1. Normally. But now there's a number out in front. When it was 2, we multiplied by 2. Now it's a half. So what are we going to do? Divide by 2 or multiply by a half. So when I go over 1, I'm only going to go up a half. Who wants to write that point? Not me. I hate fractions. When I go over 2, how far up should I go? 4. But now it's a half of 4, so what is it? So when I go to the right 2, what x value am I at? 2. And when I go up 2, what y value am I at? Oh my God. 2, -2. What is this point over here? -2, -2. Oh my good gravy. Now, if I go 3 over, I'm going to have a yucky fraction, aren't I? Aren't I? So I'm going to skip 3. I'm going to go over 4. How far up should we go if we go over 4? Normally, we would go up 4 squared, which would be 16. But now there's a half, so how far up are we going? I'm even crossing my toes. 8! What's 4 to the right of 0? 4. What's 8 up from -4? 4. Oh my God. And what would this one be over here? -4? 4. Oh, now notice that a 2 skinnies up the parabola, doesn't it? What did a half do? Stretched it out. The 2 is Mr. Myers when he was your age. The half is Mr. Myers now. Everybody understand? Because now I'm fat. Everybody cool? It's not right, man. It's not fair. Yes, exactly. Exactly. All right. Now, ladies and gentlemen, you try the last one. I have my toes crossed. I have my fingers crossed. I have my hair crossed. Go. You can do it. Don't worry, Ashton. I'm well aware that over half of you are randomly guessing. You're just putting dots on the page. You're just going to do this. Done. Oh, I'm putting a lot of eggs in this basket. Wait. A lot of eggs in this parabolic basket. You don't need bed mass, dude. You don't need any bed mass here. And stop dabbing. What? Where's the vertex? No, what does the 3 in front do? What does it affect? The stretch. So if there was no 3, it would be over 1, up 1. But now there's a 3, so it's over 1, up 3. But since it's negative, it's over 1 and down 3. And then over 2 and down Normally when I go over 2, I go how far? 4. But now it's 3 times bigger than 4, so it's... Yeah. Are you ready yet? My fingers are sore from being crossed. I need to know if I can go on. The vertex, as Jacob points out, is at 2, 6. Because you can get it right from here, yes? Now, normally I would go over 1 and up 3, yes? Over 1 and up 1. But I have to flip it because it's negative, so it's a y parabola, so I'm going down. And instead of 1, it's now 3 times bigger. So I'm going to go over 1 and down how far? 3. What is that point right there? 3, 3. What is this point over here? Automatically. 1, 3. Then, when I go over 2, I should go down how far? 4, but it's 3 times bigger, so I go down. So out here at 4, what is this point right here? 4, negative 6. What is this point automatically here? Oops, sorry. 0, negative 6. And then we make our sad parabola. Is everybody... Obviously not quite good because, counting. But is everybody at least, like beyond, you can draw curvy lines? We're past that? We're almost at you can draw curvy lines? Okay. So, here are the rules. Let's write them all out. A. What does that A tell me? Wait. Nope, I lie. Y equals x squared. In a normal parabola, if I go that way 1, how far up do I go? 1. If I go that way 2, how far up do I go? 4. If I go that way x, how far up do I go? X squared. That's a normal parabola. Everybody cool? Okay. What does the A do to this normal pattern? Normally, I go that way, x, and up, x squared. What does the A do? I go that way, x, and I go up a x squared. I multiply it. Everybody cool? What if A is negative? Negative A means what kind of parabola? No. Negative A means instead of going that way, x, and up, what do I do? Down ax squared, right? If it's A, then our parabola is going to stretch this way. If it's A as a fraction, my parabola is going to stretch that way. Is everybody cool? Yeah? Okay. P is what? That is the x value of the vertex. But what do we have to remember? It's opposite. Put a line around it, Mrs. Bad Crumble Cloud. I don't care what you do. Actually, that's dumb. That's not where we should put it. Remember, it's opposite. Now, that's what I'm going to highlight and Mrs. Bad Crumble Cloud around it. And what is the Q? Is the Y value of the vertex. And what do I remember there? It's normal. Not normal. It's normal. And I'm going to put a green Mrs. Bad Crumble Cloud around that. Okay? Your job is to do 100, 101, and 102. Oh, and 103. So I'm going to do number 1 on page 100 right now with you, and then you're going to take over. Everybody cool? All right, let us begin, cabbages. What is the vertex? Look again. -4, 1. Right? What is the equation of the axis of symmetry? Where is that line that goes right down the middle? It goes through which? The x or the y of the vertex? It goes through the x. So x equals -4. What is my range? Is this a happy or a sad parabola? Sad. It's going to go down. So my y's have to be less than or equal to what? 1. And is that a maximum or a minimum? It's a maximum at -4, 1. And then we graph it. -1, 2, 3, 4, up 1, -4, 1, and then we put in our points. When I go 1 to the right, how far down do I go? No. Yes, so how far down do I go? 3. 1, 2, 3, which is -3, -3. Sorry, -3, -2. What is this point automatically? -5, -2. When I go over 2, how far down do I go? 12. So I'm down here at -2, -11. What is this point automatically over here? -6, -11. How do I automatically know the x? Well, if I know the axis of symmetry is right in the middle and this is 1 away, then how far is that one? What's 1 plus 1? I'm surprised nobody said 8. What is 1 plus 1? What bothers me, I'm still hearing silence. Even after you made your joke, Hayden, everyone else is still like, shh, maybe it is 8. I don't know anymore. These have to be 2 apart, don't they? Because they're 1 away from the vertex. So what do these have to be? 4 apart. What's the next one going to be? 6 apart. What's the next one going to be? 8, and so on and so on and so on. Everybody cool? All right, your job is to do 101, 102, 103. Go. Yes, go to the bathroom.